The next topic, we talk about signal modulation. The signal modulation relates to the frequency transmission in the radio frequency, in walkie-talkie radio, in Wi-Fi. That is related about signal modulation. Here we have three signal forms in this picture. On the top, this is a signal that is I represent signal generated from human. Suppose is my voice is represent a signal A, and B is a signal generated from the crystal clock or frequency generator. This is sometimes called carrier waveform or carrier frequency. After I have two signals A and B, I add the signal A, add signal B, is combined A and B will be signal C. When you look at the signal C, it's changing at the top here. This is a look like the curve in the signal A. In the property inside, the changing inside, this is a look like the signal B. The signal from the radio transmitters in this is out from the antenna. This is a waveform from the antenna. It look like here. This modulation techniques we call the amplitude modulation or AM. The AM modulation, you can listen to the music from the amplitude modulation when you turn on the radio and select at the AM channel, AM station. That is a amplitude modulation. For the modulation techniques, the another modulation technique is a frequency modulation. The frequency modulation, I don't have the slide about the frequency modulation. I will search from the internet and show you and tell about the detail in frequency modulation. Here I searched from the internet, and here this is a result from the frequency modulation. Look at this picture here. This is a signal waveform. Example, my voice, and this is a carrier signal. Signal A and signal B combine and changing in the frequency. Changing in the frequency by changing the voltage at the input signal. Here in this is the signal from the voice. This is a high volt, and this is a low volt. In the high volt, the waveform is a very fixed or very or sometimes called high frequency. Here in the low voltage, this is a low frequency. If you don't understand about high frequency and low frequency, you can count it, the number of the block from the last topics that I told you how to check the frequency, and how measure the blocks I show you in the laboratory to use the oscilloscope to measure the signal. Okay, here this is example concept on the frequency modulation. Not only analog frequency modulation and amplitude modulation. In the Wi-Fi system, some system use the phase modulation. We know sine, cos, tan. The sine and cos have not the same phase. That is use the phase technique to shift the signal and changing in the phase. For the detail in this class, we cover only analog signal. Okay, we're moving back to the slide and look at the next slide. Moving back to the slide, and in this is activity 2.2, we will put the sine wave in R programming. For in this class, I don't prepare about the R programming or computer for you. You can download R from internet and install R programming. After you install R, you write the code here, and the R will show the output like as these pictures. Maybe in the class, if we have a time, I will show you and bring you to write the code to give you write the code to show the signal and simulate analog signal and digital signal. In this is a analog signal in the sine wave, and I convert from analog to digital by use the technique quantization. Quantization use the sampling to capture in each part of the signal. Here this is the large quantization or small quantization, and here this is a small quantization. When you compare the picture, the signal blue wave and red wave, the red wave is closely to the sine wave. That is because it have more quantization parameters. Now we will convert analog signal to the digital signal. From the last topics, I showed you how to simulation by writing in the R programming, convert from analog signal to the digital signal. Now I show you the theory how to convert to the analog signal and digital signal by sampling. And here in this is in each step to convert the signal. The first step, I have analog signal in blue sine wave form here. The second step, I define the number of the levels related to the number of bits in the system. For the computer system in the MP3 or the chip to generate about the waveform, this is related about the 16-bit. For the 16-bit, this is a very big, very large value. I can draw it in the picture to tell you more details. So here in this, I suppose only 4 levels. Only 4 levels. Here the levels we divided in the amplitude. Here this is level 1, 2, 3, 4. 4 level. In each box is the width of each box is equal. The third step, I suppose I sampling in 5 times in a circle. Sampling rate in 5 times in a circle, that's called 5 sampling. 5 sampling. Here in this is the 5 sampling. 1, 2, 3, 4, 5. I have a 5 sampling. This is related time, and in this is in the horizontal line related to time, and the vertical line related to the amplitude or voltage. The next step in the step 4, that is a mapping the level and the sampling in the when compared to the waveform. We look at in each point. Here in this, the first step, you like as you draw the line here from the bottom to top until hit to the blue waveform. Example, I hit in this location. In this location is close to the level 3. It's close to the level T. So I mark in the level 3. The next sampling, I move and check the hit point here, hit to the blue waveform in this. This is a map to level 4, mark in this. And here in the third, we moving up and hit to the blue waveform here. For here in this is maybe it's half between 2 and 3, but I feel it is a closely 2, so I mark in this location. And the next, the fourth, this in this point, and the fifth here, moving up to hit in this. In this is I give it to the close to the level 3. So now after that we have the position in level 3, level 4, level 2, level 1, and level 4, level 3. When you draw it, when you with your hand in the examination, in example in final examination, you don't worry about the wrong position represent 2 or 3 level. I look at the concept. I look the concept, not the error is not the concern about the right or wrong, but I look at the concept, convert from the analog signal to the digital signal. And then the step 5. The step 5, from the step 2, I told you we divided in 4 levels. For 4 levels, it is represented in 2 bit. So 2 bits is have 0 0 0 1 1 0 and 1 1. 0 0 2 bits have 1 and 2. 0 0 is represent 0. 0 1 is 1. 1 0 is represent 2, and 1 1 is represent 3. So here, then I write it in the sequence. This is a 1 0 is 1 0, and then 1 1 1 1. Next 0 1 0 1 0 0. Here 0 0, and the last 1 0. This is a 1 0. And here this is an example convert from analog signal to the digital signal. Now the activity 2.3. Let us convert the by drawing 8 level and 10 sampling.